In this video, we're going to update the Gateware on the BeagleV Fire. Really is just 4 steps. We're going to fork our reference design. We're going to tweak it, add a blinky in this case, and we're going to build it, which is really just a commit and a push up to the GitLab servers. And we're going to deploy it, which is just copying a file, downloading the files, SSHing them to the Beagle board, and running a script on the Beagle board and waiting a little bit. In the steps, I have done the fork and the customize. I'll do them again in this video. I have not yet done the build and the deploy, so that will be new for everybody. All right. So this is pretty much just following the documentation that's on the Beagle board webpage. So this is the URL for it. I'll put it in the description. If you get to the top, it's got all the Beagle bones. Here's the BeagleV Fire. Click on the demos, and then click on the customize BeagleV Fire cape using Verilog. And that takes you to here, which is also here. Same page? Yep, that clicked and it's same. Now, you may see that the steps that I had are almost, well, in fact, I stole them right out of this documentation. It's pretty good documentation. It's definitely worth reading. Right? So the first step is you go to the Gateware source code repository, and that is on Open Beagle's GitLab server. And this is the Gateware. So the first step was to fork. And so right now it's got 12 forks. See that number there? Right here. Left click on that. And this will bring you to all the forks that have been done. You can see I did this one earlier today. And so all you have to do, I'm going to create a new one. And I'm going to just, all you have to do is click on fork. And what happened? I guess that it zipped over to mine because I've already got it forked. If I didn't have it forked, then it would have asked you a few little simple questions about like your username, which is my case, Busted Wing 1, and asked you for a name of what you wanted to call it, so you could call it something else. And it's pretty straightforward. There's one small catch in that before you can fork, you need to get approved. It's a very easy, very quick, easy approval process. They're just trying to reduce spam on their servers. And so what I did was I went to this little help button down here and I clicked on it, which I went to support, and that took us to the forum. And in the forum, I happened to look over and I saw someone else had requested access to GitLab to fork Gateware. And I said, ooh, that sounds like what I need too. So I clicked on that, brought us down to this page here. And you could see that I went and I said, please enable me to fork. My account is Busted Wing 1. And so that was like 9 hours ago. And 9 hours ago, um, I was enabled. So it doesn't necessarily take a long time. It might, I don't know. But in in my case, it was very fast. Thank you very much. And so I said, thanks, it works. And so that is the only little gotcha. Let's see. So basically, we've got a fork, and so in my case, I've got a fork, and it's called My Lovely Gateware. So I click on that fork. So this is still on the Open Beagle or GitLab server. and it's here. And to click on left click on the code, you can do SSH. I do HTTPS. It's got this comment here about creating keys and stuff. I didn't do that. So I, clicked on that multiple times, triple click, Control C, and then, so I'm doing my work on the, as far as Verilog modifying, I'm doing that on a virtual machine running Ubuntu. Um, I think I probably could do it in Git Bash, but I'm doing it here, so I've got a little directory all set up to do my Beagle Fire stuff. So I'm just doing git clone, uh, paste, and so we're just going to clone that Gateware repository, which is a fork of the original. And then, as you can see, it's here. This, and then CD down into it, and less. And we've got some stuff here. If you do a find doc, that'll show everything came across. Just for interest. Hmm. So it's there we go. Excuse me. So now do is we're going to modify a YAML file saying that we're going to have a new design. I don't know where it's going to be. So right here it says, well, let's modify it. So right here, select that, Control C, go back over to here and edit it. So it comes up in an editor. And over here in the notes, it says change Verilog tutorial to my lovely king. So delete the Verilog tutorial and enter my lovely king. Oops. Save. Quit. Not bad. So now what that will do is it tells, I guess, the Gateware builder that, hey, this is the new place that we're going to be working on. And then we have to create that new place with the new Verilog code. Let me sip of water here. All right. So here, what we want to do is we want to CD down to this place right here. Control C. I'm on a CD dot dot. So that the paste. And hit return. And I'll do an LS. And so now you can see we got this Verilog template here, and a bunch of other things like GPIOs, robotics, all very nice. But what we're going to do is we're going to, well, they have it where you're making a directory and then you're copying the contents of that to the directory. And the -R means copy recursively all the directories and everything else. I am going to make this a bit bigger for now. Paste. And I'm going to hack that command line just a tad. Because I'm a big believer in just doing it one time. So that's my copy command. And that'll copy the Verilog template into my new design, which is pointed to by the YAML file that we just edited. So now then, we've got my lovely cape. Let me just take a look at what's in there. These are all the files that are in my lovely cape, which is a copy of the Verilog template. All right, so now then, we're gonna CD down into that. Where are we? Okay. Okay, CD my tab. LS. And now what you want to do is there's this file here, add cape.tickle. And again, they want to replace a Verilog template with my lovely cape. So you can use any editor you want to. And modify that. And we're going to replace all these Verilog templates. All the Verilog templates with cap locks my lovely cape. And return. Enter. Yeah, replace it. There. Not bad, huh? All right. There's gonna be one other thing. Is now so now in this one, when it adds this new design, it's telling the build tool where the new design is, which is no longer in Verilog template. It's in my lovely cape. And now what we need also is, by the way, there's a lot of stuff in this file. Don't worry about it for this example. Now so I'm just going to cut and paste this top line. Right, and now what we want to do is we're going to add, because this is the reference, this is an example from there. They wanted to do a blinky file. Who doesn't like a blinky file? Blinky. And so now we've added blinky. So that is another one of the files that will be part of our design. Next thing we have to do is create blinky. So let's save this, go down to the editor, and oh yeah, let's do a cat on add. Oops, let's do a head on add cape. And you can see that we're going to have to create this blinky.v in my lovely cape, which is where we are, and then the subfolder HDL. And that's where all these other files are as well. So we're doing cd HDL for hardware description language. We go down to here, go ls, and we have all these things that were in the Verilog example that we had copied over, which we want to keep. We also want to create one more new file called blinky.v, just like it says here in the add cape tickle file. So now we're there. Now let's go back to here. And well, I don't want to write a blinky file because somebody else wrote it. So in this example, we've got this time scale. I only put timescales in my test bench. I never put timescales in my HDL art files. And HDL is sometimes called RTL for registered transfer language. All that is silly old words for the word Gateware, which is what I think these Polar Fire, Beagle Bone folks have come up with. Never heard the word Gateware before. It's pretty descriptive. Okay, so now I'm going to paste it. Right there, that is. Oops. Doesn't look bad, does it? No, no, no. It looks like a nice file. I'm going to save this. So save it and quit out of the editor of your choice. And now, what we're going to do is we got to instantiate this blinky to some higher level hierarchy. We do an ls. Got a bunch of lower level files, including our new blinky. But right there, we're doing a cape. That cape.v is the higher level wrapper that contains all these other files. So what we want to do is use our editor of choice and go to cape.v. And here it is. Let's go back to the instructions again. And boom, what you want to do is instantiate Blinky just above the end module, which is the very tippity bottom. So we're going to get all these guys. I don't like those funny letters in my program, but we're going to have to delete those. So we're going to do select all that, do a control C, go back over here. Let's go to the bottom of this file just before the end module. Give it a little bit of room and then do a paste. And there we got it. Now I'm going to delete all these comments because those comments are pointing to doing this stuff here, which is create blinky.o, which is this instance of the blinky module. We're going to connect up the clock, P clock, which stands for, like, it goes really from the bus, like the AMBA or advanced peripheral bus. So their convention was to put a P in front of just about everything. So they got a P clock. And so we connect a P clock clock. So this is the outside signal. This is the signal within the blinky block. And then they got this P reset N, which this says S. And I think that's a little typo. So we got P reset N that we want to connect to reset the internal reset N signal. And then we want this new signal we also are adding, which we'll have to define above. These other two signals were already defined above, so they do not have to be redefined. So anyway, back to this code. We want to, I don't like those funny numbers. I like, messes up my editor. So Alt, bye-bye. Okay, so now we save that. And now what they've got is, oops, did I lose my way? I think I lost my way. Let's roll up again. Okay, so we talked about this. All right, good. So now we're in here, and what they want to do is they want to define blink as a wire. And so that goes right underneath the pre-reset end. In Verilog, you can define things as pretty much as wires here, or you also have REG registers. For this tutorial, let's not really talk about difference, except just follow what they did around it. That works just fine. So wire, let's see, wire blink. So we can remember blink. Let's find a reset N. Let's go to the beginning of the file. Control P reset N. It's all capitals. I got a case sensitive search. Okay, so it's here, it's here, and it's here. I don't think they really needed to define it in so many places. But anyway, let's cut and paste this line. I'm going to copy that line, so I'm going to cut it. I can do other things. I can do select it. Control C, Control V. All right. Now control. Now what we want to do is we want to replace P reset N with BLINK. Save it. And that is just what they wanted us to do here. So now that we've defined the blink signal as a wire, a 1-bit wire. Now then, so we've done that. So now we've got to connect it up in this cape. We've got these inputs and outputs, all these inputs and outputs. And so we want these guys to be like this GPIO enable. It's a 28-bit value. So there's 28 GPIO output enables and 28 GPIO values. Wait, those are inputs. It's not what we want. Sit. Sit. Let's think about this for a second. GPIO out, if they call it an input. Does that really make sense? GPIO out net. So they're gonna go after this net thing. So let's see what this guy is in here. So we're gonna select that, Control C, the top of the file, Control F, paste. Let's see what this signal is. So it's a wire, a very big wire. So 46 down to 3. So that's like 44 bits, right? Yeah, so just subtract 3 off, subtract 3 off. That would be 43 down to 0. So that's 44 bits. Um, so that'd be interesting to see what they'd be doing with this signal. So we've got, but anyway, so for, I guess we can dig into it later on and debug it. But for now, let's keep with the script here. And so we've got we want to replace these two lines with these two lines. So I'm just going to select and copy, Control C. I'm going to come back over here, edit and paste. And now we got them. And again, I'm going to get rid of these comments with the ones and twos. All right. So I got that. And let's comment out the lines that were there beforehand. And so what that's doing is that's hacking into here that we want this particular bit out of this 46 down to 3. We want this bit, I guess that's the lower 5 bits, the 6th bit to be a 1. And then we want out of the lower 5, the 6th bit to the blink. And so that output enable means, I guess that's a 1 active high. So when a particular bit is a 1, that means that a driver going to the output of the FPGA is enabled and it's driving out. And then we're going to be driving out our blink signal. And that blink signal is coming from our blinky block. And I don't know, should we talk about the blinky at all? So for the blinky. All right, so blinky, it's got a counter. Every clock cycle, the counter's going to increment, increment, increment. It's got, this counter is 23 bits, 22 down to 0. Whenever the gets up to where it's counted so that it got all up to 0 and all ones, then it flips so that then it goes to like there's a 1 in the most significant bit. It's gonna, so whenever that you get to a really big count, blinky goes on. Then when the counter gets to the max, very max, so all the bits are a 1, the next count, everything's going to roll to a 0. Blinky will go off. So blinky will be off for half the time. Gets the upper range, blinky will be on for half the time. So 22, 23 bits. That is, let's see. So nice little trick I know is 10 bits is 1K. 20 bits is 1 meg. 30 bits is 1 gig. Kind of nice, isn't it? 10, 20, 30. So anyway, like we've got 23 bits. So 20 bits is 1 meg. 3 more bits, 2 to the third is 8. So that's 8 meg. So for I believe 4 meg counts, it's going to be blinky will be off. Then 4 meg counts, blinky will be on. So that is blinking 8 meg. I was guessing, but I don't know, that this blinky FPGA was running at about 100 megahertz. I really doubt it's less than 50 megahertz. So if it's running at 100 megahertz, that's 100 counts per second, 100 million counts per second. And we're going only up to 8 meg. So I'm thinking this Blinky is going to be fast. We shall see. So anyway, that's Blinky. Let's get the heck out of here. Let's go back over to this. Sorry for the sidetrack. We've got this guy here going, and yes, even says everything in the documentation. Really nice documentation. So the next thing is we got to do something with this device tree overlay. I'm pretty much an FPGA guy, very little bit into Linux. I guess I'll have to get there eventually. Oh, we want to save it? Absolutely. All right, now then, so let's say where the device tree is. Uh, no, I don't see it. Maybe it's in there somewhere. But fortunately, I've already done this. I already found it. And we go cd dot dot pwd, just so you know where we're at. We're in my lovely camp with ls. And right there is a folder called device tree overlay. So cd down into that, ls. And there's one file into that. So edit that one file, Verilog Cape DTSO. I guess what's device tree something overlay. All right. And now what they want us to do with this, they wanted us to change something right about here. It looks like that good old replace Verilog cape with my lovely cape. I write this, Control C, Control F, Verilog cape. Right, so I found it. And I'm going to paste right over that. Boom. So I just replaced Verilog cape, Control Z, Control Y with my lovely cape. Control S, Control Q, say bye-bye. And now, could we be done with this? This is as far as I got before, because I did not have a fork. So I could not fork, but now I can. Well, well, well. Mm, add the directory content to your Git repo and add this. All right, so I'm going to do it slightly different. Okay, so I'm going to do right here. I'm going to do Git status. I always love doing Git status. And look what it's done. It said that we have modified this my custom FPGA design, the YAML file, because it already existed. And then we have untracked, but so which means new, um, our my lovely cape, which is a copy of the Verilog. So see, we got the same thing if we go up one level. Yeah, and then we go up another level. Yeah, so it keeps pretty much telling you my lovely cape. So what I'm going to do is I'm going to say git add, and the thing's in red. So I just, selected them. On mine, it's like a what? I don't know, double click with the left button, and then I middle clicked and it pops it right down on the line, on the command line. And then I'm going to hit return. And now I'm going to do a git status. So here we just had two little entries here. If you look at it, oh, I got to spell it right, git status. Now look what we got. So it's telling you that we've added my lovely cape and all the files below it, including our wonderfully complex blinky module. And we got the DTSO that we know that we tweaked to point. Let's see. So that we changed the Verilog something template to my lovely cape. Here we changed. So let's see. I wonder, can you do a git diff on this guy? No, because we've already added it. When they were red, you could do that. I'm sure there's a way that you can do it, but I'm not that smart on the git stuff. All right. So anyway, we got all this done. It now. What we want to do is git commit -m. So that's going to commit it to our. This is going to commit these changes to our local repository that's on our PC. Whatever. Chrome. Locally. It's going to commit it to our local Git repository. The -m means a message. And so it's always good to put in some sort of message. So, blinky. That's good. Now, hit a return. All right. And now we do a git status. And what it's saying is that your branch is ahead of origin main, which is my fork that's in my account and my account on OpenBeagle's GitLab server, which is a fork of the one from the BeagleV Fire official one. So it's the fork. And now what we've got here, all this niceness, is now what we got to do. This is exciting. Let's git push. And when we push, this is going to send it up to the GitLab server. And the GitLab server, and this is new to me, the GitLab server is going to go and it's going to start the build process and it's going to build everything. Usually something like this, when I do it on Libero on my local machine, takes about like 20-ish, 30-ish minutes. So I'm not interested in how long it's going to take. We're going to do a git push and then it's going to churn away. We'll go back up. We'll go up to that um, GitLab site into my account, and then we're going to start looking at the artifacts, and let's see how long it takes to actually build and get artifacts that we can then download to back to our local machine, and then send over to our BeagleV Fire FPGA SoC with all those wonderful RISC processors. So here we go. Oh, who am I? Oh, I am busted. What is my password up there? I don't remember. Oh, that's it. Good news. Look at that. That's kind of uneventful. But let's do a git status before we pop up there. And now your branch is up to date with origin main. Nothing to commit. Working tree is clean. Gotta love that. Okay, so I think we're pretty much done what we need to do. Now, let's go back up to here. So we're in our browser. Let's reload. That's a big message for something that apparently I don't even need. There's nothing wrong with using the HTTPS, is there? I'll stick with it until it doesn't work for me. So we're building. So I'm going to go down. And we got all these things I don't know about. But if we go to the notes, okay, so is the fact. So let's find fire Sure, why not? That should get us this page here. Brings us back to here, which brings us down to demos. Let's see, is that right? Yeah, it brings us down to demos, which brings us to customize, rename. This is what I've done. Where we all the accomplishments. So we've done this. We've done the git add. We've done the git commit. We've done the git and now it's saying that we gotta retrieve the forked repositories artifacts. So let's see. We want to select some sort of archive. This will result in. All right, so we got pipeline here. You see my lovely Gateware project, pinned issues merged. If we go to this guy, looks like things have changed a little bit. But right here, the pipelines, that looks kind of pipelines. It looks like what we're going after. So let's just go over. So when I hover over build, that pulls over this little pop-up window. Slide over to it, and I'm going to left click on pipelines. Well, look, status is running. So I wonder if the clock is accurate. That really means it's like what would be 3/4 would be here, half would be there. No, somewhere between. It'd be nice if that was cool. Um, so I think I'm gonna probably shut it down while we patiently wait for this thing to stop running. And then we will go and see if we can find some artifacts, which is, I guess, here. And we'll get some artifacts. And when we have artifacts, I think we should be able to download them. So let's hang out for a little while.